Imagine a junior supply chain analyst goes on a 2-week vacation, right?
Mm.
And suddenly, a massive pharmaceutical company's global logistics just, well, grind to an absolute halt.
Oh, yeah. A total nightmare scenario.
Completely. And why does it happen? Because the entire routing system secretly relied on like a few undocumented tweaks that analysts made in a personal spreadsheet every single Tuesday at 4 p.m.
Which is terrifying if you run a business, but honestly, it happens all the time.
It really does. So, welcome to our deep dive. I'm so glad you're joining us today because we are looking at a radical new software architecture. It's designed to extract that unwritten vital knowledge straight from the human brain and basically wire it into an AI.
Yeah, we are pulling from some incredibly dense but deeply important source material for this one. It's excerpts from the Palantir Ontology, a decision-centric architecture for AI agents.
Okay, let's unpack this. Our mission today is to understand how enterprise AI is moving way past, just storing data or building chatbots.
Right, it's moving into the real world.
Exactly. We're going to look at how it's being designed entirely around making, executing, and learning from physical, real-world decisions.
And it is a fundamental shift in how we view the utility of software. I mean, to understand why this matters to you, whether you manage a hospital system or a logistics hub or a bank, we have to look at the prime directive of an organization.
Right, what is the actual goal?
Right. The ultimate goal isn't just to accumulate and store massive amounts of raw data. The goal is to execute the best possible decisions in real time, often while everything around you is in a chaotic state of flux.
Well, wait, hasn't the tech industry spent the last, decade telling us that just cleaning and unifying our massive data lakes is the holy grail?
Oh, absolutely they have.
So why is this document suddenly arguing that relevance is the principal problem? Like, why isn't clean data enough anymore?
Well, cleaning data is certainly a prerequisite, but the process of unifying it often flattens out the messy, complex reality of a business into very rigid, narrow schemas.
Okay, what do they call those?
The tech industry refers to these as golden tables. They are rows and columns that look fantastic on a quarterly performance report.
But I'm guessing there's a catch.
Yeah, they lack any actual operational context. True relevance requires capturing the context of operations exactly as they happen in the moment.
Oh, I see.
Yeah, so the source material refers to this new model as a decision-centric architecture rather than just, a data-centric one.
So it's like if you have a kitchen pantry completely overflowing with ingredients, right? But you have absolutely no recipes and no chef to actually cook a meal.
That's a great way to put it.
And if you've ever worked at a large enterprise, you know exactly what this golden table problem looks like. You get a beautiful sanitized spreadsheet at the end of the month.
But it tells you nothing.
Exactly. It tells you absolutely nothing about the frantic emails or the canceled orders or the manual overrides that actually went into making those numbers a reality.
Precisely. If a traditional data lake is just, say, a CCTV camera passively recording traffic at an intersection, a decision-centric architecture, what Palantir calls their ontology, is the traffic light system.
Okay, actively deciding who goes when.
Exactly. It's actively deciding who goes and remembering which timings prevent accidents. It integrates all modalities of data, from structured databases to streaming edge sensors, into a full-scale semantic representation.
That sounds massive.
It is, but more importantly, it captures what the text calls decision data.
Decision data. What does that actually mean in practice?
It's the context surrounding a choice. It's the options a human evaluated and the downstream implications of what they ultimately chose.
So wait, if it's capturing the entire environment of a decision automatically, does that mean it's logging the exact state of the database at the exact millisecond the human clicked approve?
Yes. Yes, it is. The source introduces this as decision lineage.
Decision lineage. Okay.
It automatically captures when a decision was made, on what specific version of the data and through which application. And that lineage is the absolute bedrock of giving an AI a functional memory.
Wow.
Yeah. By securely capturing that context, the system can continuously refine different forms of agentic memory. The text outlines 4 specific types working: episodic, semantic, and procedural memory.
Okay, let's translate that a bit. In humans, procedural memory is, well, like knowing how to ride a bike, right? It's muscle memory.
Right.
How does a piece of enterprise software develop muscle memory for something like global supply chain routing?
Well, it develops that memory by combining the raw data with the logic used to process it, because human reasoning is usually what orchestrates a business workflow.
Yeah, that makes sense.
But the ontology uses a concept called logic binding. It watches, for example, a veteran supply chain manager consistently ignore a certain system warning during heavy rain.
Oh, because they know from experience it's a false positive.
Exactly. The system captures that specific interaction, that heuristic, and encapsulates it into a logic asset.
That's wild.
It is essentially looking over the human shoulder, learning their unwritten rules, what the text calls their tribal knowledge, and packaging those rules as tools the AI can use later.
Okay, I completely get how a system captures hard data. But the source also mentions surfacing deterministic functions to complement the non-deterministic reasoning of large language models.
It sounds incredibly academic, I know.
Yeah, it does. What does that actually mean?
The mechanics are actually pretty straightforward. Large language models, the engines behind chatbots, are non-deterministic. They are probabilistic.
Meaning they guess.
Basically, yeah. They guess the next best word based on patterns. That
Uh.
makes them highly creative and adaptable, which is great for drafting an email.
But terrible for calculating exact warehouse capacity, right?
Oh, absolutely terrible. Deterministic functions, on the other hand, are strict rule-based math, standard algorithms, forecast models, standard business logic in an ERP system.
Ah, I see. So, if data are the nouns of the business, then this logic is the grammar that dictates how those nouns interact.
That's exactly it. By binding them together, the AI gets to use the strict, inflexible math as a tool to verify its creative problem solving.
It's giving the creative brain a calculator.
Yes, perfect analogy.
Okay, so we have a pristine, automatically updating memory of how the business operates, and we've given the AI the logic to reason through that data.
Right.
But thinking about a problem doesn't physically move pallets in a warehouse. How does the system actually act?
Closing that action loop is really what distinguishes a true operational system from a purely analytical dashboard.
Right, because a dashboard just flashes red to tell you a shipment is late.
Exactly. It's a completely different thing to have a system automatically reroute the trucks and update the billing software.
So how does it do that safely?
The ontology models both human and AI actions as sandbox scenarios.
So staging a scenario is like a flight simulator for business. You get to see if the plane crashes in a simulation before you actually execute the real-world maneuver.
That's the exact intent. The AI explores the trade-offs in an isolated environment before writing anything back to the live enterprise substrates like transactional systems or edge devices.
I gotta say, this raises my anxiety a
I
bit.
know. How so?
Well, if we're giving fleets of AI agents extensible tools to make operational choices, how do we guarantee a rogue agent doesn't hallucinate and permanently overwrite our core manufacturing databases?
That is the most critical hurdle for enterprise AI, honestly. And it's addressed through a deeply integrated security model.
Okay, how deep are we talking?
The security in the ontology moves far beyond simple buckets of data or basic role-driven access. It relies on marking-based, purpose-based, and role-based policies that are dynamically computed at runtime.
Dynamically computed at runtime, meaning it's checking the rules every single millisecond the AI tries to take an action.
Every single millisecond for every individual data point.
Wow.
Let's break down those policy types. Role-based security asks, are you a supply chain manager? Marking-based security asks, is this specific piece of data tagged as classified or sensitive?
Right. And purpose-based security asks, even if you are a manager and you have clearance, are you accessing this classified data specifically for an officially approved audit?
And if you aren't?
If the AI agent or the human doesn't meet all three of those criteria in the exact millisecond it tries to act, it literally cannot see the data, let alone change it.
So an AI agent cannot query data across organizational boundaries if it doesn't have the granular permission. It can't hallucinate a connection to an external system because the architecture strictly dictates what tools the agent is even mathematically aware of.
Exactly. And crucially, the actions themselves can be severely limited. An AI might be given the power to stage a brilliant idea in that flight simulator environment, but the policies can physically require a human to hit approve before a single line of code is executed.
Okay, to really ground this, the source material details a very specific high-stakes operational crisis. Let's look at the Onyx Incorporated example.
Good idea. Onyx is a fictional medical equipment manufacturer used in the text to illustrate these mechanics.
Oh, and they run into a major problem, right? Yeah, they face a sudden, unexpected disruption with a major supplier of raw materials. This disruption immediately threatens their production schedules for surgical masks, which cascades into threatening customer orders.
Now, in a normal disconnected enterprise, solving this would require frantic phone calls between the warehouse managers, the suppliers, and the distribution centers.
Right, people running around with their hair on fire.
Totally. You'd have analysts pulling data from 5 different conflicting spreadsheets trying to figure out the blast radius of the problem.
But Onyx uses their ontology. It synthesizes all those siloed systems into semantic objects. So an operations leader deploys an AI agent called Disruption Bot.
Disruption Bot, I love that name. What does it do?
It immediately scans current stock levels, real-time production metrics, shipping manifests, and crucially, past after-action reports from previous disruptions.
Oh, the decision lineage we talked about.
Exactly. And because the ontology surfaces all of Onyx's deterministic logic assets, their rigorous forecast models as AI-ready tools, Disruption Bot runs a massive battery of simulations in seconds.
Here's where it gets really interesting. Because the AI has this dense context combining strict math with creative problem solving, it surfaces a novel material reallocation strategy using a newer machine learning model that the human analysts hadn't even considered.
Right. It stages the entire plan in a secure scenario and hands it off to a human analyst for final review.
And that is human agent teaming in practice. The AI did the heavy lifting, but the human retains the final authority.
Yes. The human evaluates the business context and approves the action.
But wait, let's look at the messy reality of corporate IT. The text notes that Onyx grew by acquisition. They have a delicate mix of completely different IT systems.
Oh, it's usually a mess.
Right, so how does hitting approve on an AI chatbot actually force 3 decades-old legacy ERP system to physically update without breaking them?
The ontology addresses this through highly specialized write-back routines. When the human approves the scenario, the system doesn't just blast out a generic sledgehammer command and hope the legacy systems understand it.
Thank goodness.
Yeah, it automatically orchestrates a set of updates tuned specifically for each receiving system's native safeguards.
So rather than forcing a 20-year-old system to accept modern code, it translates the action into whatever strict rules that older system requires.
Exactly. For the modern warehouse management system, it might send a clean API update. For the 3 legacy ERP systems, it uses native ontology-driven connectors that abide by their specific operational rules.
And for the other systems.
For the production planning system, it might just generate a consolidated flat file for it to ingest asynchronously overnight. It executes complex physical actions while keeping the IT team in full control, generating detailed telemetry and logs.
Okay, so the surgical masks get made. The customers get their orders. The immediate crisis is averted. But the true value of this entire architecture isn't just fixing today's problem, is it?
No, not at all.
It's what the system does with that memory tomorrow. Which brings us to the final concept in the source material, the loop, or continuous learning.
This is where a decision-centric architecture fundamentally outpaces a purely data-centric one. The human agent teaming that solved the Onyx crisis just generated incredibly valuable new data.
Right. Every single data element the bot checked, every logic asset the human utilized, and the exact sequence of actions taken were securely captured.
Securely captured in that end-to-end decision lineage.
It's like the entire company is giving itself an automated, perfectly documented performance review after every single micro decision.
That's exactly what it is. And the aggregate of those decisions, made by thousands of users and agents across the enterprise, becomes rich training data.
To fine-tune the models.
Yes. It distills that unwritten tribal knowledge into targeted principles for future AI prompting.
That's amazing.
And as humans gain confidence in the agent's performance over time, the security policies can be dynamically adjusted to grant those agents wider purview.
So they can execute routine actions without as much manual oversight. The source material actually notes this isn't just theoretical, right? They list real-world applications happening right now.
Yeah, they do, yeah. American Airlines is using it to power AI-enabled network planning.
Managing the massive complexity of routing flights.
Exactly. The U.S. Army Software Factory is deploying operational applications in days instead of months. Novartis is transforming drug discovery, and Andretti Global is turbocharging their IndyCar operations.
Processing telemetry data in real time using human agent teaming. That is a wild range of use cases.
But if we connect this to the bigger picture, across all of those incredibly varied environments, from a racetrack to a pharmaceutical lab, The core philosophy remains the same.
Which is what, exactly?
The system maintains a real-time pulse on the physical operation, ensuring that the AI is never just a chatbot operating in a vacuum, but an active participant anchored in reality.
So what does this all mean for the human worker? If the system is constantly capturing human decision lineage to train the AI to be smarter, to permanently capture their tribal knowledge, is the end goal just to make the human a rubber stamp?
That's a huge question.
I mean, are we just training our replacements here?
It's a really understandable fear, but the text emphasizes the exact opposite approach. The ontology does not replace the human, it actually relies on them.
How so?
The real world is chaotic, ambiguous, and constantly evolving in ways no algorithm can perfectly predict. The AI needs human trust and human intuition to securely navigate that chaos.
Oh, I see.
The system merely scales the human's ability to respond to reality. It removes the friction of searching through 50 spreadsheets so the human can spend their energy actually strategizing.
It takes the chef out of the pantry where they're just counting ingredients and puts them in front of the stove where they belong.
Exactly.
So to wrap up this deep dive, what we've seen today is a fundamental reimagining of enterprise software. By combining data, logic, action, and security into a single architecture, organizations can finally bridge the massive gap between just having raw information and actually taking intelligent action in the real world.
It transforms AI from a passive oracle you ask questions of into an active, secure, and continuously learning participant in your daily operations.
Incredible. I want to leave you with a final provocative thought to ponder today, one that builds on everything we've just discussed.
I love these. Let's hear it.
The source material emphasizes that this architecture captures the unwritten tribal knowledge of your best human workers to train AI over time. But think about what that means for the future of your own career.
Right?
If an AI agent can perfectly mimic the nuanced, gut instinct decision-making of a 30-year industry veteran simply because it has comprehensively studied their exact decision lineage, does the true value of human experience begin to shift?
That's a heavy thought.
In the near future, maybe being an expert won't mean knowing all the answers. It will simply mean knowing which questions to ask the AI. Because as we've seen today, the chatbot phase was just the waiting room. Now the AI has its hands on the actual controls of the physical world. Something to think about until our next deep dive.